Scholarly.2018. Giving back so you can get ahead.
Hi, welcome to Scholarly.2018. In our last video, we talked about graphing linear equations. We went through the introduction to the coordinate plane. We went through quadrants, intercepts, and introduction to slope. This video is going to be solely about slope and the equation that we'll use for graphing a line from your linear equation. This will be your linear equation. What this is, y equals mx plus b. This is something to write down, jot down in your memory, write on your wall, push pin it to the wall. So let me break this down for you. We have a y equals, mx plus b. Now m, we talked about in the last video, was the variable for slope. So that's all that's going to equal is our slope, is our m. We have our x coordinate, and then we have plus b will be our y-intercept. Okay, so you might see an equation that looks like this: y equals 1/2 x, plus 4. We say, Now, what do we know here in this equation? Well, we have our y-intercept. We know the coordinates. Now, the y-intercept. What is the x-coordinate for the y-intercept? That's going to be a 0. So we know that in our y-intercept, the x-coordinate, the first coordinate, is going to be a 0, and then we see this is a positive 4. So we have our y-intercept right there. It's positive 4, and our slope is given to us right here. That's 1/2. Now, if we look back to the equation that we had before, we started off. We said the slope equals. This is how we're actually finding the slope, and what the slope is. It was the delta y, which is the change in y, over delta x, which is the change in x, and that was y2, right? Your final minus your initial, right? And also over x2 minus x1. What we see here is we have our y and x coordinates. That doesn't change when we get here. So I'm going to show you two different ways that we can get this equation on a graph. Using just our slope and our y-intercept. Now we can go ahead and figure this out. The way we'll figure this out is we'll have to put in values for x. So let's go ahead and do it the long way, or the correct way first, and we'll put in values for x, and we'll figure that equation out. We'll do it right here below it, actually. So we'll have y equals, and what we want to do here is we'll say we're going to put a value for x, and a value for y, all right? And we're just going to do 2, all right? And we'll say the first value for x is 2, and the second value for x is 4, What we want to get is we want to get what that y equals, So we have 1x plus 1/2 x plus 4 here, So when x is 2, we're going to have half times. So let's go ahead and plug this in to see what we have for our y value. We have 1/2 x, so we'll put y equals, and we have 1/2 x. That's 1/2 of 2. 1/2 of 2 is going to equal 1 plus 4. So we have y equals 5. We can put that there. So when x is 2, all right, y is going to be 5. That's our first ordered pair, right? 2, a positive 2, 5. That's our first point on our graph. We'll do the same thing for the bottom one. When y equals 4, all right, that'll equal 2, because when x equals 4, we have 1/2 x. That'll equal 2 plus 4, and that'll equal 6. So we have that one, 6. We have 4, 6. All right. Let's take these points over to our graph. So we have 2, 5, and 4, 6. All right. So we'll go over 2 and we'll go up 5. 1, 2, and we'll go up 5 and put our first point right there. All right. And then we'll go over 4. 1, 2, 3, 4, and we'll go up 6. So our next point will be right here. All right. Let's grab this ruler here. It's kind of running into my my other coordinates over here, but we'll go around them. All right, we'll grab this ruler, we'll go through these lines, we'll draw a line with these points, okay? Now, what I have here, if I'm going over 2 and I go up 1, okay? Watch this. I want you to see this. So down here we have from this point, okay? From this point, our 2, 5, okay? So we'll write that 2, 5 as our point here. And then we have a 4, 6 as our other point here. And I know that's kind of small to see, but I want to show you something. If we take this point, this 2, 5, and we go over 2 on our x, and we go up 1, we're going to meet the line again, right? Which is actually our 4, 6 coordinate. Yeah, it's our 4, 6 coordinate. But if we go over 2, we go up 1. We went over 2. We'll try to get it in line here. Went over 2, 1, 2, and we went up 1. Okay, that's our slope. We went over 2 on the x-axis. That's our bottom number, and we went up 1 on our y. Okay, so this is our y. This is our x. Over here, what did it say? We have the slope, so that fits in our equation. Those points fit in our equation. All right. So we can do it the same way over here. All right. We can start with our y-intercept because we know our y-intercept is 0, 4. Let's try that. Let's try 0, and we'll go up 4. So 0 is on our x, and we'll go up 4. 1, 2, 3, 4. And we'll put a point right here on 0, 4. All right. Now, let's do this. Let's pick any other point using this slope. So what do we say? Our y-axis, vertical, is on the top, and our x is on the bottom. So we have 1/2. Let's go over 1 for our x. We're going to go over 2, and we're going to come up 1. And what do we have? We're right there at 2, 5 again. All right. Now this line is a little bit wonky, but we're at the right. We're at 2, 5 again. So this would actually fall right in line with that. And it's really important to have measurements and use graph paper when you can. And doing it this way because you'll end up with some crazy kind of answers. But those are 2 different ways to find slope. So let's recap really quick. What we did here is this is our equation for slope, okay? The m equals the slope, and our b is the y-intercept. So what we did is we recognized that the change in y over the change in x equals our slope. So what we did is we picked 2 values substituted for x. All right? We started off with y equals, this is our initial equation, y equals 1/2 x plus 4. So we know the slope and we know the y-intercept. Okay? We know the slope and we know the y-intercept. So now we're going to substitute values for x, and what we want to do is say, this is pretty much a function. That says when x equals 2, you enter 2 into the equation, what you'll get out is a y value of 5. And how we did that is y equals 1/2 x, 1/2 of 2, okay? 1/2 times 2 will give us a 1 plus 4. 4 plus 1 is 5. Now we have our other values. So when x is 2, y is 5. Same thing for here. 4, when x is 4, we're going to get 6, okay? And then we brought it over to the graph, and we graphed it. And then we double-checked it because we saw that our x value, which is our bottom value, all right, we want to move left to right first, and it's a positive value, so we took it 2 places to the right, and then our y value was on top. We moved it 1 value up, and we got our other point. And that's how we checked our slope. And then we went back and we did it an easier way, is we just graphed the point from the y-intercept directly, which was 0. We didn't move left to right, and we moved up 4 for the y-coordinate, okay? For our x-coordinate, our y-coordinate. So we didn't move up, and we didn't move left to right, but we moved up, okay? And we plotted a point there, and then we took our slope, and we said, okay, we're going to move 2 to the right. We're going to move 2 to the right, 1, 2 in the positive direction, and 1 up. And we're going to meet another line. We're going to put another point right there. And we know that that's our slope. So that's an easy way to graph linear equations using y equals mx plus b. And we'll show you a little bit more dealing with this. I'll get the board cleared off, and we'll start into another realm of information that you can plug in using these equations, and just you get a good visual on how slope is working. All right, so now I'm going to introduce to you what's called a point slope equation or point slope form. I want to describe how this works. First of all, this is our slope intercept. And we'll write that up here just so we don't forget that. It's slope intercept form or slope intercept equation, right? And we all know how that works. Intercept. What we'll be talking about is our point slope form. I'll go ahead and write that up here also. Point slope form, or I like to use equation. And you'll be asked on some of your testing to write information in either slope intercept equation or slope intercept form or point slope form or point slope equation, and not fully get the entire answer. So I want to show you right here. Normally what you'll end up getting is you'll end up getting an ordered pair, and we'll just make a simple ordered pair here. 2, 4. That's 2 on the x-axis and 4 on the y-axis. So 2 over to the right and 4 up. All right. And the way the point slope equation works is, so we'll have what you'll be given is you'll be giving a ordered pair. So a specific point on a line. We'll put that point here. So we'll go up over 2, and we'll go 1, 2, 3, 4 up, and we'll put that point here. And again, these aren't measured out, so when we go ahead and draw the line, we're not going to be able to do our, we're not going to be able to just add and find out our what our slope is. But in this instance, our slope will be given to us. So it'll say the slope m equals, and we'll say that this slope equals 2. Okay? So we're given that information. We're given our 2 coordinates, and we're given our slope. So we can plug this into the equation here. Let's plug it into our slope intercept form. So y equals, and we'll say we know that our slope is 2x plus b, because we don't know anything else. Okay, we don't know anything else. Now, what's going to happen here? I want to show you. So we've talked about how to find slope, right? And the slope m equals the change in y, okay, the change in the y coordinate over the change in the x coordinate. Or we're going to take this as y. I like to do 2 just to know the y finish minus the y initial, okay, and then over x end, or x2 minus x initial, okay, or x1. So let's look at that, okay. We have, that's an equation here where we can manipulate that, and like we've done in fractions and things like that, we can manipulate this equation. We do have some of these values, okay. We have one of the points on the line, so we can choose any of these, the x or the x2 or the x1, the y2 or the y1. So let's rewrite that equation without the change in, all right? And we can say that m, or slope, will equal y2. Actually, let's flip it around the other way and have this y2 minus y1 over x2 minus x1, okay, equals the slope, okay, because that's what it does. The change in y over the change in x, right? Those are the change in y over the change in x equals the slope. So what can we do here? This is really simple. This is nothing but a fraction, right? And if we wanted to isolate one of these, numerator, what we would do is we would multiply by the denominator. And what that would do is cancel out the denominator, x2 minus x1. It will cancel out the denominator. But what we do on one side of the equation, if we remember, we have to do on the other side of the equation. So we'll come over here and we'll add that, or we'll multiply the slope by that. x2 minus x1, right? And these cancel out. So our new equation that we're left with, is, and I'll have to get down a little bit for this one, y2 minus y1 equals slope times x2 minus x1. All right? That right there is our point slope form. Okay? This is our point slope form. So let's take a look. So we have our point slope form now. We can go ahead and punch in numbers, can't we? We know a couple things here. We know that our slope is equal to 2. So let's put that in up here. Let's do y2 minus y1 equals the 2, that's our slope, okay, times x2 minus x1. All right? Now we have points. We have an x and a y point, don't we? We have an x here and a y here. All right? We can put these in anywhere. What we like to do is we like to keep it on the initial side. Okay, so we have a 2 here. So we'll rewrite this equation y, okay, and we're just bringing down this one, okay. We'll just say y minus 2, okay, equals 2. I'm sorry, we're wrong. We're wrong already. There we go. Y minus 4 is our y coordinate, right? Y minus 4 is our y coordinate, equals 2 times, and we'll use the same coordinate, okay? We want to keep this x here. We don't want to get this mixed up and put this x for this x. Remember, we have to keep our initials and our finals together, okay? Minus x, we just brought that down. I'm sorry, times x minus, and then we have our x coordinate, which is 2, okay? So now, our new equation, y minus 4 equals 2x minus 2. Now, we're going to use the distributive property of multiplication first and foremost before we do anything else to this equation. We're going to stay within the order of operations so we get the right answer. This is paramount that we do this, because if we start subtracting and adding to both sides of the equation, we can't take anything out of here. When we go to add 4 to cancel this out, we can't take it out of here. Okay? We have to do that when it's a sole number and it's by itself. So we're going to go ahead and multiply the 2 times the x and then the 2 times the negative 2. And we're going to get our answer over here. Okay, so we'll bring this still down. We'll bring it down. Y minus 4 equals 2 times x is what? 2x. Okay? Then 2 times negative 2. We want to keep the sign. Remember that. Okay? 2 times negative 2 is a negative 4. We have that right there, right? So now we have y minus 4 equals 2x minus 4. What we're going to go ahead and do here is we want to isolate this y. So we're going to add by 4 on this side, and what we do on one side, we're going to have to do on the other side. So we're going to add by 4 over here as well. Okay? We're going to get 0 over here, 2x, okay, plus 0 is just 2x. Y equals, okay, because this canceled out, right? This canceled out, it equals 0. Ended up canceling out for us. So we have y equals 2x plus 0. We can't go anything further than that. However, what does this look like? So if they're asking you, they give you 2 coordinates and they say, I want you to put this in a slope-intercept form. Well, we've just done that going through our point slope equation. Okay? Now this y equals the slope 2 times x plus the intercept, b. We know that this line is going to go somewhere right through the 0, 0 point, okay? Because we know that our y-intercept is when x equals 0, and our y-coordinate is 0 here also. Okay, so we know that our x and our y is going to be 0 for this equation. So if we wanted to graph that, y equals 2x plus 0, what do we know? We have a point here, 2 and 4, right? 2 and 4, 2 over, 4 up. We have a point there. And we also know that our y-intercept, where our where our point crosses the y-axis is at 0, okay? We know that both of our coordinates are 0, so we're going to have this right here, right there. And if we drew a line through that, we know right here, well, my line's a little bit off, but we can see also that this might match up. If we take from 0 and we go 2 over and we go 2 up, we're going to land on that line. We go 2 over again and we go 2 up, we're going to land on that line, okay? That's how we get to this point slope form, this slope intercept form, because this is the same thing as y equals mx plus b. And this is our point slope equation. If we're given coordinates and the slope, we can find out how to graph from that using our slope intercept, our point slope equation. Okay? We'll write it down here again, point slope equation, so that we can not screw that up anymore. Point slope equation. And a point slope equation you use when you have a coordinate on a line and you have the slope. Okay? And then what they'll tell you to do on your test or anything like that is they'll tell you to put it into slope intercept form. There it is. Very simple. So your answer right here would be y equals 2x. And that would be your most simplified answer in slope intercept. All right, thanks for tuning in to Scholarly.2018. This has been our presentation on graphing linear equations and slope intercept form and point slope form for finding slope. We went over quadrants and intercepts and our coordinate plane and how we can manipulate different things in our equations to get answers. As always, I want you to like and share and follow. Tell your friends. The more users we get, the more we're going to deliver this free content to people. All right? See you later.